In a single photograph, this telescope sees 100 times more of the sky than Hubble. This is what Hubble sees. This is what Roman sees. It launches in 5 months, and most people have never heard of it. The first complete map of dark energy, thousands of new exoplanets, and the answer to whether life exists beyond Earth. One telescope, 5 months. In this video, what Roman can see that Hubble never could, the dark universe it will map for the first time, and why some scientists are genuinely afraid of what it might find. Also, the woman who made it possible, who worked at NASA for 20 years and never received the recognition she deserved until after she died. Hubble launched in 1990. It is still operating 36 years later, and it is one of the most scientifically productive instruments ever built. But Hubble has a fundamental limitation. Its field of view is tiny. It was the middle of it, that is approximately what Hubble sees in any single observation. To build the famous Hubble ultra-deep field image, the one that showed 10,000 galaxies in a single frame, Hubble had to stare at the same tiny patch of sky for 11.5 days. Roman does not have this problem. The Roman Space Telescope has the same size mirror as Hubble, 2.4 meters, but its camera, the wide field instrument, covers a field 100 times larger. In a single 6-minute exposure, Roman photographs more sky than Hubble observed in a year. To map the area of sky that Roman will survey in its first year, Hubble would need more than 1,000 years of continuous observation. The practical implication: Roman will detect more galaxies, more stars, and more objects in its first 12 months of operation than all previous telescopes combined. But the scale of the images is not what makes Roman significant. What makes it significant is what it was built to find. 95% of the universe is invisible. Not dark in the sense of unlit, dark in the sense that it emits no light, reflects no light, and cannot be detected by any instrument we have built. 27% of the universe is dark matter. We know it exists because its gravity affects visible matter. We have never seen it directly. 68% of the universe is dark energy. We know it exists because the universe is expanding, and the expansion is accelerating. Something is pushing it apart. We do not know what that something is. Dark energy is the most significant unsolved problem in physics. Roman was built specifically to investigate it. By mapping the positions of 2 billion galaxies across the universe, Roman will create the most detailed 3-dimensional map of the large-scale structure of the cosmos ever made. That map will tell us how dark energy has changed over time, whether it is constant, which Einstein's cosmological constant predicts, or whether it is evolving, which would require rewriting physics. We will know within 5 years of launch. The second major mission of Roman is to find planets, not by looking at individual stars directly, by using a technique called gravitational microlensing. When a planet passes in front of a distant star, the gravity of the planet bends the light from that star, creating a brief, detectable brightening. This technique can find planets that are impossible to detect by any other method. Planets far from their host stars, small rocky planets like Earth, and rogue planets, worlds drifting through space with no star at all. Astronomers estimate Roman will discover between 2,000 and 500 and 100,000 new planets in its first microlensing survey. For context, before James Webb launched, we had confirmed approximately 5,000 exoplanets in total. In the history of astronomy, Roman could multiply that number in a single survey campaign.
The telescope is named Nancy Grace Roman. She was the first chief of astronomy at NASA. She joined the agency in 1959, 1 year after it was founded. At a time when women in science were systematically excluded from senior positions at every major institution, Roman built NASA's astronomy program from nothing. She designed the concept for a large space-based telescope that could see the universe without atmospheric distortion in 1969. That concept became Hubble. She was not invited to the Hubble launch. She spent the last years of her career working as a contractor at Goddard Space Flight Center, not as a senior scientist, not as a director, as a contractor. The same institution she helped build from the ground up in 1959 hired her back decades later in a support role. She kept working on space science until she was in her 80s because it was what she loved. Not because anyone was paying attention. She died in 2018. NASA named the Roman telescope after her in 2020, 2 years after she was gone.
There are two outcomes from Roman's dark energy survey that physicists are quietly concerned about. The first, it confirms that dark energy is a cosmological constant. This sounds like good news. It is not. If dark energy is constant and the universe keeps accelerating, then in approximately 20 billion years, every galaxy outside our local group will be moving away from us faster than the speed of light. Invisible, unreachable, gone. Any civilization that exists in the distant future will look at the sky and see only darkness, with no evidence that other galaxies ever existed. The second possibility is worse. If dark energy is not constant, if it is evolving and growing stronger, then the expansion may eventually tear apart not just galaxies, but solar systems, then planets, then atoms. This scenario is called the Big Rip. Roman's data will tell us whether it is possible.
The calculations suggest the Big Rip, if it happens, would occur approximately 22 billion years from now, which sounds like a long time. But consider this. The universe is currently 13.8 billion years old. We are not even halfway through its current lifespan. Whatever is out there, whatever civilizations exist or will exist, they all face the same ending if dark energy continues to strengthen. Not a collision, not a freeze, a tear. Every atom in the universe pulled apart by the expansion of space itself. Roman will tell us if that future is real in 5 months.
In October 2026, a SpaceX Falcon Heavy rocket will carry Roman to the L2 Lagrange point, the same orbital position as James Webb, 1.5 million kilometers from Earth, where it will spend at least 5 years mapping the invisible architecture of the universe. 2 billion galaxies, hundreds of thousands of new planets, the first direct evidence of what dark energy is. We do not know what it will find. That is the point. Every telescope we have launched has shown us something we did not expect. Hubble showed us the universe was older than we thought. James Webb showed us galaxies that should not exist. Roman will show us something else. James Webb already found galaxies that broke our models. The video on what James Webb has discovered and why it matters is next. Subscribe to Untold Universe, Tuesday, Thursday, Saturday.